When people talk about coding, most of them know it has something to do with if and else. If something is true, do something. That's how we talk to our computers, and this is called logic. Logic is not terribly exciting by itself, but it is a really powerful tool that you will need at some point in your patching career. That's why we are dedicating a tutorial to it. So put on your learning cap and let's get started. The largest portion of logic in wire consists of nodes that compare two values. The values are compared and the output is either true or false. True or false, does that ring a bell? Yes, all comparators output booleans, which we have learned about in the fifth tutorial in this series. The most commonly known comparator is equal. It outputs true if the left value is equal to the right value and false when not. As for the rest of this patch, the true or false boolean is sent to the switch. This node switches its output depending on the incoming boolean. If true, we render the circle with a green color. If false, we render it red. I'll deep dive into the switch node and its bigger brother, the gate node, in a separate tutorial. All comparators have an opposite node. In the case of the equal node, this is the not equal node, which does exactly the opposite. When the integer in is not equal to 3, the not equal node turns true and we switch to a rectangular shape. Here we have two new comparators, greater and less. The greater node turns true when the left value is greater than the right, and the less does exactly the opposite. I smoothly sneaked a little smooth node in here that smooths the color transition. This is just a little trick you can start using too. And even more comparators. Say hi to within and outside. These are two comparators you don't see in many programming languages. Within outputs true if the input value lies within the range. This is set with the min and max parameters. The outside node does the opposite. In this example, the sine node goes into the hub node, and the hub node does exactly nothing. It's just a node for cable management. The signal from the sine continues into the pack where it becomes the x of a float 2 value. This value moves the circle back and forth. Note how we use the same sine oscillator twice, once for the movement of the circle and once for the logic controlling the color. This next bit might be interesting for the power users out there, and that is that comparators can also be used on textures. We'll discuss these kind of operations in a future video as it is quite an advanced topic, but for now know that pixels are essentially just numbers. In case of this little example, the fractal noise gives us values for R, G and B that range between 0 and 1. We are comparing this to a gray color, which has RGB values that are 0.5 or the middle point between black and white. We expect that the greater node will output true for the values that are above the threshold and false for the values below it. True, pixel is 1, false, pixel is 0. But as I already said, we will dive further into this in the advanced course. And with that said, we have finished the comparator nodes. I have two more nodes to show you before we wrap this up. The if node will convert a boolean into a trigger. In this example, we have a unipolar sine running from 0 to 1 and back. This modulates the size of the pentagon shape, which is here as a reference. We check if the sine is greater than 0.5. We use onChange to change from the signal to event flow, as the if node only operates on event flow. If the sine is greater than 0.5, we trigger the first attack release node, which modulates the size of the circle. If the sine is not greater than 0.5, we trigger the second attack release, which modulates the size of the rectangle. This is an abstract demonstration to show you the if node can be used to trigger something in your patch when a certain Boolean condition is met. And lastly, we have the toggle node, which will convert a trigger back into a Boolean. Here we use the toggle node in conjunction with the transport beat node to toggle the pixelate effect on and off on each beat. Good stuff. That was it for now. In my personal experience, you will naturally know when you need a logic node while patching. Do I need to compare something? Logic node. Do I need something to do when a certain condition is met? Logic node. Do I need to manipulate booleans? A logic node. And that was it. And after such a long tutorial, I'll be an awesome teacher and not give you any homework. I'll see you in the next video.